In this video, we will see how to score good marks in theory papers. Scoring good marks in theory papers involves meticulous preparation and effective presentation. As for preparation is concerned, in the classroom, what you need to do? Your first preparation actually starts in the classroom, so you have to listen well in the class, watch carefully how terms are pronounced and how they are written in symbols, and you'll have to take down the notes. At home, you have to go through what you have written and patiently recall what was learned. After learning thoroughly, try to test yourself by asking questions to yourself and write the answers. Compare your answer with the notes taken. Correct yourself if you have gone wrong anywhere. Now, let us use an illustration to understand how to prepare yourself to learn about S3. So in algebra, this S3 refers to the symmetric group on three elements. Suppose you have S to be the set consisting of these three elements, 1, 2 and 3. Then S3 is the set of all permutations on S, that is S3 is the set of all one-to-one mappings of S onto itself. Now we are going to prepare to find out the members of S3, where S is already set 1, 2, 3, the set consisting of 1, 2, 3. Now we have considered sigma to be a permutation, so that means it should be 1 to 1 and 1 to, which means see here in this case your domain and codomain are the same. So your domain consists of 1, 2, 3, and also your codomain will consist of 1, 2 and 3 only. So your sigma can take 1 to 1. Once you fix that, then sigma can take 2 to 2 or sigma can take 2 to 3. Now once you fix sigma taking 1 to 1, 2 to 2, naturally sigma has to take 3 to 3. And here sigma takes 1 to 1 and 2 to 3 means naturally 3 should be taken to 2. Then in the same way, if sigma takes 1 to 2, sigma 2 can be 1 or sigma 2 can be 3. So once you fix sigma taking 1 to 2, 2 to 1, naturally 3 has to be taken to 3. And here 1 is taken to 2 by sigma, 2 is taken to 3 by sigma, therefore 3 has to be taken by 1. Now suppose sigma takes 1 to 3. In this case, sigma of 2, that is the image of 2 under sigma can be either 2 or it can be 1. So again, if 1 is taken to 3, 2 is taken to 2, 3 has to be taken to 1. And here 1 is taken to 3 by sigma, 2 is taken to 1 by sigma, and therefore 3 has to be taken to 2 by sigma. Now this can be represented in two row notation like this. That is, you have the elements in the domain in the first row and the corresponding images in the second row. So this we shall call as epsilon. And in this case, you have 1 being taken to 1, 2 to 3, 3 to 2, 1 to 1, 2 to 3, 3 to 2. So this is named as gamma. And here this 1 is taken to 2, 2 is taken to 1, 3 is taken to 3. This is named as alpha. And the next one, 1 to 2, 2 to 3, 3 to 1. Cyclically it is written. So this is delta. And the next one, 1 taken to 3, 2 to 2, 3 to 1. So this is your beta because 2 is fixed. And the last one, you have 1 is taken to 3, 2 is taken to 1, 3 is taken to 2, and this is denoted as theta. Now we can notice that in the case of alpha, 3 is fixed. In the case of beta, 2 is fixed. In the case of gamma, 1 is fixed. And as for delta is concerned, cyclically it is written. That is, you have 1 being taken to 2, 2 to 3, 3 to 1. And for theta, the previous one, 1 is taken to 3, 2 is taken to 1, 3 is taken to 2. So in this way you can write the elements of S3, epsilon, alpha, beta, gamma, delta, theta easily. Now you can test yourself whether you have understood the concept and do it for S4. where S consists of 4 elements, 1, 2, 3 and 4. So here S4 will consist of 4 factorial elements. There we had S3 consisting of 3 factorial elements, namely 6 elements. So here again, we can suppose I have my sigma taking 1 to 1. Then the choices for sigma to take 2 could be 2, 3, 4. Suppose I have 1 being taken to 1, 2 being taken to 2, then how my sigma 3 will be? Sigma of 3 will be 3, or it can be 4. So once 1 is taken to 1, 2 to 2, 3 to 3 are over, naturally you have sigma of 4 to be 4. So in this case, 1 to 1, 2 to 2, 3 to 4. So you have to have your sigma of 4 to be just 3. So in the same way, we can complete the entire process, and finally we will arrive at 24 elements. After completing this, you list out the elements of S4, which is the symmetric group of degree 4, and you will have like this. So once you achieve this, yes, you can celebrate. Your hard work can be celebrated by yourself. Now we will see how to present the answers in examination effectively. You have prepared something and you want to present it, how effectively that you can present it. So let's have an illustration for this. Suppose the given question is, obtain the commutator subgroup of quaternion group. Second one, the symmetric group of degree 4. Now to answer this question, you should know the definition of a commutator subgroup and what is a quaternion group and what is S4. So you obtain, to obtain the commutator subgroup of quaternion group, first we shall consider that. You remember that GPTC rule, what is given, what is to be proved, and what is the technique involved, and then the conclusion. So quaternion group, we know that G is, if it is denoted as G, then it consists of the elements plus or minus 1, plus or minus I, plus or minus J, plus or minus K, 8 elements. Now our job is to find the commutator subgroup, which is denoted as G prime of G. Now what is commutator subgroup? Commutator subgroup is the subgroup generated by the set S of all commutator elements of G. So S is nothing but the commutator elements of G. Then what is commutator element? It is denoted in this way. It is A, B, A inverse, B inverse. So this must be written first. So this is the main part of your proof, that the technique, what is the technique that you are going to use. So for that, you must know what is the definition of commutator subgroup. So that has to be written. Then you start computing. So you take A as I, B as J. Then you compute the commutator of I and J. It is by the definition I, J, I inverse, J inverse. So I inverse in the case of this quaternion group is nothing but minus I, and J inverse is nothing but minus J. And we also know that I into J in the quaternion group is K. So we have this minus into minus, you have plus sign, and I into J is K. And you know that K dot K is minus 1. And similarly, we can compute when A is minus I, B is minus K. Then you compute your commutator element A, B, that is minus I minus K. So you have A, B, A inverse, B inverse. Then this I minus sign into minus sign, so that is taken, and so you have just I into K. Minus I inverse is I, and minus K inverse is K. And when you have I dot K, it is minus J. When you have K dot I, it is J. When you have I dot K, it is minus J. So you have minus J into minus J, so that is minus 1. So similarly, if you compute this, so you have this must be actually I square is minus 1, this must be plus 1. This one is plus 1. So when you compute for all the combinations, so you will see that your S is just 1 and minus 1. And since S is 1 and minus 1, and it is also the subgroup of G containing S. So commutator subgroup of G prime is nothing but 1 and minus 1. Now, instead of presenting the answer for this question in this way, it can also be presented in the following way. But of course, step 1, step 2, step 4 will be the same. There is just a change in step 3. So how else that the same thing can be presented? So this one will take more time, but the following method will quickly give you the answer. So that is, let me explain this. Let N be a subgroup of a group G. This is the result that we are using. Let N be a subgroup of a group G and let G prime be the commutator subgroup of G. Then this result says that the subgroup N is normal in G and G by N is abelian group if and only if N contains the commutator subgroup. In other words, G prime is the smallest normal subgroup of G with an abelian quotient. That is, if you want to compute your G prime, you find out the normal subgroups of G. And among the normal subgroups, you must find the smallest one so that G mod that smallest normal subgroup should be abelian. That quotient group should be abelian. So if you use this result, then in few steps that you get the correct answer. That is, the proper normal subgroups of G are known. This is should be known to you. So A is one subgroup, B, C, and D. All of them are normal subgroups. This is obvious, and the index of B in G being 2, and similarly C and D, they have indices 2. They all are normal, and this one is also a normal subgroup. So G mod A can be defined, and the order of G is 8, order of this is 2. So 8 divided by 2, 4, which is 2 square. Any group of order P square is abelian, so G mod A is abelian. And here index is 2, index of B in G is 2. So being a prime number, that should be abelian. So G mod B is abelian. Similarly, G mod C abelian, G mod D is also abelian. But among all the normal subgroups, you have the quotient of all of them to be abelian, but A is the smallest normal subgroup of G with an abelian quotient. And so the conclusion is the commutator subgroup is nothing but your A, and that is the set consisting of 1 and minus 1. Now, see, it is presented. So this is one of the answer sheet that is taken for illustration. The same question, obtain commutator subgroup of quaternion group and S4. Now for quaternion group that we will consider. So as said earlier in step 1, quaternion group, what is that? That has to be written. That is written here. So that's okay. Then what is the aim? To obtain the commutator subgroup G prime of G. So that is not mentioned here. The commutator subgroup contains the element like this, it is given. That is not expected. What is given you have to write, and what is to be done, that should come next. And then you have your computation. So in step 3, you should mention what is meant by commutator subgroup. That is not mentioned directly. Commutator element is considered. So all these steps are to be written. That is not written here. So care should be taken to write all this. And of course, conclusion is there. So here, not all the computations are carried out, but it's very time consuming to compute all of them. So it is written. Similarly, you can compute the rest. So even that is allowed, but it should work as well. So if it doesn't work, then you cannot come to a conclusion. So this process will be definitely time consuming. That is allowed, but it is time consuming. So conclusion is given. So as for this paper is concerned, you're having step 1 correctly, step 2 not mentioned, step 3 is not clearly done, step 4 is given. So accordingly, marks will be cut. So presentation should be taken care, and how it has to be written, it has to be written in that way. So if you use this method, then you can easily have the solution. So when you have two solutions for the given question, um, have it in your mind. Just because it is asked, suppose it is asked for 20 marks, unless you write it elaborately, that marks will not be given. Yes, here you can present like this, but if it is asked for 20 marks, then the proof of this result is to be given. So that is the only thing that you need to remembering the proof of this is better than calculating the whole lot. So in that way, if you present, then that will fetch you good marks. Now we have the second subdivision is for S4. You need to compute the commutator subgroup. So here again you need to write what is the G. G is your S4 and that is given here. And in step 2 you have to obtain, you have to tell that what is given, what is to be proved. Here you are going to obtain the commutator subgroup G prime of G. What is G? G is S4. And you'll have to write the definition. As mentioned earlier, you have to write the definition and commutator element, how it is defined. Now here, as you did elaborately in the case of quaternion group, if you start computing, definitely it will take more time. So see here in this paper, the student has done like this. It is not concluded properly. Of course, here it is mentioned that every 3 cycle is a commutator, but this kind of answer will not give you full marks. Okay, what is the marks allotted for the particular step? Okay, you can get that, but you will not get full marks. So here just S4, even S4 is not correctly mentioned. So this is wrong. And commutator is an even permutation. Where is the proof for that? So even that is not done. You have considered only 2 members, and that too the elements from the first row. Okay, this one will account for the elements in the first row. How about the second, third, fourth individually, or if you have one from here, one from there, and any combination for that matter. So it will be time consuming. So here, of course, if you have done like that, then you can conclude that since S is this, and is the subgroup A4 of S4 containing S, then commutator subgroup G prime of G is A4. Like that, you can conclude. There is another name given to this G prime, that is called derived subgroup. So instead of presenting like this, which is time consuming, as said earlier, in step 3, we can adopt this method. You will have to mention the result, what was said earlier, the same result. In other words, you can remember this. G prime is the smallest normal subgroup of G with an abelian quotient. Now, in the case of S4, the proper normal subgroups of S4, see, there is no need to consider the trivial or improper normal subgroup of S4, which are just singleton epsilon and S4 itself. In no way that from that you will get your required answer. So you consider only the proper normal subgroups. Even there, in the case of quaternion group, we consider only the proper normal subgroups. So in this case, we have only these 2 proper normal subgroups. But when you compute this S4 modulo V4, this quotient group, it will have, see, this has got 24 elements and this has got only 4 elements. So naturally, the quotient group will have 6 elements. So this group which has got 6 elements, we have only 2 choices. One is Z6 under addition modulo 6, the other one is S3. And we are borrowing this result that S4 mod V4 is isomorphic to S3. We are not proving that here. And this is non-abelian. See, for this result to be used, we need to have the quotient to be abelian. But we know that S3 is non-abelian. And so G prime cannot be V4. This possibility is ruled out. So then what should be the conclusion? If you consider S4 mod A4, the order of this is 24, order of this is 12. So this quotient group has only two elements, and two element group is isomorphic to Z2, and that is obviously abelian. So by this, it is the smallest group because this is ruled out. Even this is smaller than this only, but the quotient is not abelian. So here this right candidate is your A4. And therefore you conclude that G prime, that is the commutator subgroup of S4, is just A4. So the only way to do great work is to have passion in what you do. When you're passionate about something, your mind is constantly engaged and actively seeking new ideas and solutions. This leads to greater creativity and innovative. You can be innovative in your work. When passion aligns with purpose, it becomes a powerful catalyst for achieving great work. So, all the best for your future endeavors. Thank you.